Hey guys, Nate's dad here. I wanted to talk about limit switches this time. We felt that the limit switches were necessary to sort of protect us from ourselves, if you will. So we have limit switches currently implemented on X and Y. You can see the kind of switch we used here. These aren't wired up yet on X, but it's a little lever arm micro switch. We got these from Jameco.com. Although there are tons of vendors and sites that you can get those from. Um, I'll talk about the wiring last, but I wanted to talk about the mechanical interface, which was probably the biggest challenge of figuring out limit switches. I didn't see a lot of footage on the web regarding limit switches, so we did a lot of original design, I think, in both mechanical and electrical wiring. So let me move down here so you can get a better view of the Y-axis switches. You can see it's two of those switches, two of those little micro switches mounted on a piece of aluminum angle. The aluminum angle then is screwed nice and tightly to the main mounting bolts for the mill itself. So that provides a very rigid structure for the limit switches to sit on. This little block here, I'll try to zoom in without getting too fuzzy, was actually added. It's a 1/2 inch by 1 inch piece of solid aluminum stock. I counterbored and drilled a hole through and used a cap screw to screw it nice and tightly to the steel of the Y-axis. There was an extra hole there in between the other screws that are provided for the jibs. I wanted a plastic interface between the actuator of the switch, so I added that little piece of G10 out there at the end. I think it's G10. You'll have to ask Nate. But it's fiberglass material, and that worked out very nicely. As you can imagine, the Y-axis runs back and forth in this direction, and when it gets close to the end, it trips the switch, and that ends the motion. I'll demonstrate that last because it takes a little bit of mouse clickery to get you out of it in Mach 3 once you've tripped the switch. I didn't say at the beginning, but I am particularly interested in feedback on this setup. We didn't, as I said, I didn't see a lot on the web regarding limit switches on mills like this, so this is what we invented, and definitely open for comments. Now if I can get myself off the ground here, I'll show you the way the X-axis limit switches work. I added this little piece of 1/4 inch by 3/4 inch stock here, aluminum stock again, cut to a very precise length that replicates the travel of the X-axis. As you can imagine, as X travels back and forth, and as X travels back and forth, it gets closer and closer and closer, and eventually that switch will trip. They're not wired now, so I don't actually want a chance breaking the switch, but that's how our X-axis limit works. Very simple. Now, one note about the wiring for that X-axis, those switches do move, so I'm going to have to use a particularly sturdy type of wiring for that, and what I've chosen to use is wire that's designed for on-stage microphone use. It's a 2-conductor shielded wire that has a lot of additional strings and reinforcement inside of it, so I think that'll work well in this application. So that's our X and Y limit switches. Wiring now was yet another challenge, but pretty straightforward. You can see under here the wiring for the Y-axis. It's a 4-conductor shielded cable. I didn't want to use shielded cables for these signals. A 4-conductor shielded cable. 2 of the wires come up to the one switch in the front, 2 come to the back and the back switch. I did shield that little bit of run in between the 2 switches, just to be a little bit over the top. I took all 4 conductors back to the little interface panel that was built to allow us to interface the, trying to move the light here, a little interface panel that we put together under here that allows us to interface the individual discrete wires back to that DB9 connector that runs as a shielded DB9, a cable that runs back to the main box that you may remember from prior videos, and there's a DB9 on the back for the input signals. I don't know if you can quite see it, but up on top there's a signal ground and a shield. Those are separate. The shield goes back ultimately to the chassis of this silver box here, which ultimately goes back to earth ground. The signal ground, however, goes to the electronics, so those two things are two separate things. Down below there's provisions for a lot of strain relief, which we wanted to do throughout to make sure that the wires can live a nice long life. That's pretty much it. Oh, I do want to highlight this little gizmo, which we bought from a company called Gravitech. It takes the DB9 in on one side and provides a place to screw discrete wires on the other side, and that was very helpful in interfacing between the DB9 that comes out of the box and the discrete wires that come back from the limit switches. So as I said, I'm very interested in feedback on this limit switch arrangement, and feel free to provide that in the comments. Thanks. Talk to you next time.